Hello friends, welcome to Gyanmurti channel. Dear friends, in chemical properties series of alcohols, today we will discuss about reactions involving cleavage of carbon hydroxyl group bond. The carbon oxygen bond in tertiary alcohols is weaker than in the primary alcohols. As we know, alkyls are electron releasing group, that is positive I effect, that is inductive effect. In this type of reactions, tertiary alcohols are most reactive and primary alcohols are least reactive. As we have the order of the reactivity here, so some typical reactions involving the cleavage of carbon hydroxyl group, that is bound in alcohols, are described here. Here is reactions with hydrogen halides. As we know, hydrogen halides on treatment with an alcohol gives haloalkane, and the order of reactivity is tertiary alcohol, uh, secondary alcohol and primary alcohol, and below here given, that is hydrogen iodide, hydrogen bromide and hydrogen chloride. The reactivity of hydrogen iodide is more than that of HCl, that is hydrogen chloride, and hydrogen bromide is in between the reactivity of hydrogen iodide and hydrogen chloride. The reactivity of alcohol HCl is lower than that of HBr and HI. Primary and secondary alcohols react with HCl in the presence of catalyst, that is anhydrous zinc chloride, ZnCl2. The reactions of HCl with tertiary alcohols does not need a catalyst, and here it can react in room temperature. So dear friends, ethanol gives chloroethane with HCl. In these reactions below we have given that C2H5OH, that is ethanol, plus HCl, that is gas, on treating with anhydrous zinc chloride, that is ZnCl2, and little bit heating, it gives C2H5Cl, that is chloroethane, and H2O water. Similarly, 2-propanol, that is uh, here is the 2 releasing group. As we know, electron releasing group, that is alkyl group, is present here. One is CS3 and another is also CS3 plus HCl. In room temperature it gives CS3 to CHCl, that is 2 chloropropane plus H2O. Here the cleavage of hydroxyl group, that is OH group, with and bonding with chlorine takes place, and the reaction, we have the mechanism and we will discuss it later very clearly. And here tertiary alcohol, that is 2-methyl 2-propanol, on treating with HCl gas at room temperature it gives 2-methyl 2-chloropropane plus water. On treating with alcohol with hydrogen iodide in presence of red phosphorus, it gives alkane. Here primary alcohol, that is CS3CH2OH ethanol, on treating with hydrogen iodide in presence of red phosphorus, it gives ethane plus iodine plus water. And the mechanism of reaction is here. The reaction of an alcohol with hydrogen iodide proceeds the following steps. Number one is protonation reactions, that is proton of alcohol. Protonation of alcohol, here is we have the formula, that is ROH, that is alcohol, on treating with that H plus, that is H plus of hydrogen, it may be any halide, hydrogen halide, It gives ROH2, that is oxonium ion is obtained because we know oxygen is an oxygen and hydrogen bonds are polar bonds. Here the partial negative here is the pair of electron present and which gets bonding and form the oxonium ion, which is of positive charge. The positive charge of on oxygen weakens the carbon hydroxyl group bond, that is COH bond, leading to its cleavage, and the reaction is slow and carbonium ion, that is R plus, and water is created here. Similarly, nucleophilic attack by X minus on R plus, that is hydrogen halide have two components. First one is H plus and another is X minus. X minus, that is chloride bromide iodide, when reacts to form haloalkane, and the reaction is so very fast. Here is the nucleophile, that is X minus, that is any chloride bromide iodide are nucleophiles which gets reaction with the positive charged alkyl group to form haloalkane. And another we have reaction with phosphorus halides. As we know, PCl3, PCl5, PbR3, Pi3, etc. are the phosphorus halides. And when phosphorus halides treated with alcohols, it gives haloalkanes. For example, we have when ethanol CH3OH, CH3CH2OH, when treated with PCl3, it gives chloroethane, that is 3CH3CH2Cl plus S3PO3. And similarly, another tertiary butanol, that is CH3,3COH, on treating with PCl5, that is phosphorus pentachloride, it gives CH3,3CCl, tertiary butyl chloride plus POCl3 plus HCl. Another, we have reaction with thionyl chloride. Thionyl chloride is the SOCl2, that is sulfurous chloride, in the presence of pyridine give haloalkanes. Ethanol gives chloroethane when treated with thionyl chloride, C2H5OH. Ethanol plus SOCl2 in presence of pyridine, it gives chloroethane C2H5Cl plus HCl plus SO2, sulfuric oxide, sulfur oxide. Sorry. Another is reaction with ammonia. As we know, alcohols on treated with ammonia, that is NH3, in presence of heated alumina Al2O3, to give a mixture of primary, secondary, and tertiary amines. Here, alcohols is converted into amines, and in the above, there is converted into particular halides, that is phosphorus halides and thionyl chloride on treated, it gives the respective alkane and HCl and SO2 in the above reaction. And here, on treated with ammonia, it converted into amine, that is one uh, functional group can be converted into another functional group in presence of heated alumina Al2O3. We have to remember this reaction and this condition, that when one functional group can be converted into another functional group in organic chemistry, a very important reaction here. C2H5OH plus NH3 untreated with Al2O3 360 degrees Celsius. The ammonia having three number of hydrogen, one hydrogen can be uh, combined with ethanol's OS group, and it forms water, and which releases on and forms the ethyl amine, that is C2H5NH2, and again on treated with ethanol in presence of heated alumina it forms diethylamine, and similarly on treating with ethanol in presence of heated alumina it forms triethylamine. Thanks for watching this video. Please have any query, then you can comment in the comment section. Please like, subscribe, and press the bell icon for more updates. You can see this in our playlist series. Thanks.